packets. Anytime we're making forwarding decisions on layer 3, we call that data packets. It's just a name we use, packets. I don't know exactly how it arranged from that. I don't know the history, but we call them packets. Our layer 2, our data link layer. It controls how data is formatted for transmission. We use MAC addresses here. And instead of calling them packets, we call them frames. Okay? And then our physical is the layer that is of the physical world, which means physical just doesn't mean that we're putting data onto bits of a wire. The wire itself is considered physical. Anything we can physically touch. A router is physical because it's a device we can touch. Logical means it's something that we can't physically touch, but it is something that exists. But then you have to say, well, does it really exist because it's logical? But it exists because we interact with it. That's why. You can have the philosophical idea later on, whether it really is physical or not, or logical or not. So, things that you can physically touch, wires, equipment. Now, that's one aspect. But when we're putting the information on the wire, we're dealing with voltage, timing, maximum distance. There's only so far that this data can go. If we go back and look at our Ethernet types, we can see that 10 base T only goes 100 meters before it will start having problems. So is 100 megabits per second or 100 base T. Even 1 megabits per second over twisted pair. Still, we got the same limitation. But a gig over fiber gives us 5,000 meters, man. That's a big change. That's a big change. It might not be 5,000. It might be 500. So, make sure you research that. I'm not a cable guy. Neither are you. So this information is nice to know. But it's not, you might get question this on the CCNA exam. I mean, don't get me wrong. So this is what really the OSI model is for. You can go really deep and to find out what it's for. And I mean really deep. Or you can do what I did with this information and use it just as a means and a tool to find out how one PC communicates with another. And that's all I do. Okay? So if I wanted to communicate with one PC to another, let's think about this. PC 1, PC 2. PC 1 is going to send data over to PC 2. He's going to take his application data here. He's going to put his header over the data. He's going to put his presentation information here to make sure that his presentation is sent in a way that he wants PC2 to see it, and how he wants PC2 to present that data to the user. The session will be created to make sure that communication between 1 and 2 is up, maintained, and stays up until it needs to be terminated or torn down. Our transport layer will tell us what ports that we are communicating on. It'll also let us know if it's UDP traffic or TCP traffic. Remember, UDP is best delivery. TCP is guaranteed delivery. Then we get to our network layer, which is layer 3. That's going to be what? And actually, this information goes right here. The layer 3 information is going to have the source IP in there and the destination IP. Now, what is the source IP? The source IP is the PC of the one who's sending the data. So if this PC is 192.168.1.1, his source IP will be 192.168.1.1. If this PC is 192.168.1.10, and he's trying to communicate with PC2, his destination IP address will be 192.168.1.10. He's also going to go to the data link layer, and that data link layer is going to put in what? Source MAC and the destination MAC. All this information gets set onto the wire as electrical signal. That data gets sent over here, going out the network card now. This is where we're leaving the network card. The network card itself is putting this information into electrical signals and sending that electrical signal over the wire. That data comes over to here, comes into our network card. And now the network card looks at it and says, okay, what's the destination MAC? He's now looking at the layer 2 information that came from PC1. And he's going to say, okay, let me open this up. He opens up the layer 2 information. He looks at the destination MAC and says, oh, well, that's my MAC address. If it wasn't his MAC address, he would drop the whole data and say, see, that's not for me. I don't care. But since it is, since the layer 2 information has the destination MAC address of me, as I'm looking at this data, that means it belongs to me. So I'm going to strip this off. And now I'm going to look at the layer 3 information. The layer 3 information is going to have the source and destination IP address. I'm going to look at the destination IP address because this is an ingress packet here. It's ingress. It's coming into me. So if it's coming into me, I need to be concerned with the destination data. I'm not sending it out. It's information coming to me. I know what the difference is. And since it's inbound on my interface, I looked at the destination layer 2. I saw that was me. I took that off. And now I'm going to look at the layer 3 information. Now this makes sense, right? Because when I originally get this data, I'm not going to see all of this. Only thing I'm going to see is the layer 2 information. So I'm going to open this up, remove this, and then I'm going to see the layer 3 information. Oh, well, that makes sense. Let's open this up. Let's find out who this belongs to, who this is going to. So I'm going to look at the destination IP address that was sent from PC1, and now it's sitting at my network card. Oh, the destination IP address is 192.168.1.10. Well, that's me. So if it wasn't me, at this point, I would drop it. If it was going to 192.168.1.5, guess what I would do? I would drop that data. But since it's going to 192.168.1.10, I'm going to go ahead. Since it's me, I'm going to say this belongs to me. I'm going to go ahead and strip this off and now see what's underneath. So it's pretty interesting how this works because we're not going to go any farther if any one of these steps doesn't belong to me. So now I'm going to look at the layer 4 information. I'm going to look at the destination port if it has port numbers in there. If it's got a port number of 55 and I'm not listening on 55, I drop it. I decided, nope, sorry, I'm not listening on this port. You're not getting through on that port number. So the data gets killed. It gets blocked. If that destination IP, or my destination port number is 55 and I'm listening on 55, I will allow that traffic to come in. Okay? The session is still doing its job, maintaining what it's supposed to be doing. And now this PC is going to look into this information and say, okay, this is how you want me to present it to the data? It's present the data to the user? I'm going to do that. I'm going to use this to make sure I'm presenting it to the data correctly. looks at the application information and says, oh, okay, this is the application we need to be using. This is where the application is going to, so on and so on. Technically, the port number will define where it's going to, but I'm going to use that application information to make sure I open it up, and I'm going to make sure it's presented correctly. Then that information comes up, and now I can finally see the data that I wanted to see. And while you're looking at this, you're saying, wow, that's a lot of information. That's a lot of steps.